And we're back after watching that video. Now I want to talk a little bit about evolution and natural selection. So we watched that evolutionary psychology video narrated by Liam Neeson, which of course was probably wonderful for you all. And then we're going to look at natural selection and evolution. These are biological concepts, but again the idea is we can apply this to psychology. The environment selects the fittest organism. So if you live in a cold climate, it's better for you to be fat. If you live in a hot climate, it's better for you to be thin. So the idea is that it's kind of the survival of the fittest. Again, it's selection. It selects the fittest organism. So over time, these biological traits become more or less common in a population. So imagine if somebody was born with X-ray vision. I mean, I know it seems crazy, but imagine how useful that would be. And what would probably happen is they would survive, they would thrive, their children would survive and thrive, and that would, nature would select that because it's adaptive. It's something good. And let's say somebody is born with the, we even talked about, it sounds terrible to say, but I don't mean this in any bad way. We talked about that friend of my daughter who was born with the myelinization deficiency. That is a mutation, which we'll talk about on the next slide. And that is a mutation where she's not going to have children. So that mutation is not adaptive, and that mutation, nature does not select for that. And a mutation that is adaptive, nature selects for that. And it's not, when you say select, there's no intelligence at work necessarily. It's simply saying that they will survive if it's adaptive, and they will not survive if it's not adaptive. And over time, adaptive traits thrive and non-adaptive traits don't. And then what this leads to is evolution. And I know that's a loaded term, and I know you've talked about it in biology, but really I just want you to think of evolution as change. It is something that means that over time, inherited characteristics of successive generations, you will notice a change. So are humans different now than they were 300 years ago? Yes. That's what we mean by evolution, that we are taller, we're different in many different ways. We're more intelligent, we have all of these different things. So we change over time due to natural selection. So that's what we're talking about. And there's a video here that we can watch, but I'm just, instead of making a really short video here, we'll get to this video here in a minute, which I think will illuminate some of that, but let's look at the next page. So we talked about a mutation. Mutations can happen for a number of different reasons. Sometimes they just happen randomly. So a mutation can happen from radiation. It can happen from any number of different things. But if it mutates, then a child is born different than their parents. And as that mutation, and it can be adaptive or not, and what we have is all of these mutations are actually really good because it makes for a great variety of things. And if we have a variety, nature sort of selects for the things that are adaptive, doesn't select for the things that are adaptive. We talked about epigenetics in a previous, I think it was yesterday. We talked about epigenetics, and the idea of epigenetics is simply that genes will be turned off and on based on the environment. So these are all closely related. So you can see how a mutation in a gene, a change in a gene, can affect not only whether a species survives or not, whether a person survives or not. It can affect how traits keep going in the long term. So some things just die off, some things thrive based on how things mutate and how genes are expressed by environmental factors. I mentioned it again, I mentioned it yesterday, but I'll mention it again. Schizophrenia is a good example of epigenetics, where many people are carriers of a genetic predisposition to schizophrenia, but sometimes an environmental factor like stress or a traumatic event or maybe taking a lot of LSD can cause that gene to quote-unquote turn on, and that's what we're talking about with epigenetics. And then that, that can cause certain things too that are adaptive and non-adaptive, so you can see that change over time. And then the last thing I want to talk about, this is something we talked about during the quiz yesterday too. We talked about the two pots. We have a pot of plants that are in good soil, getting good water, getting sunlight, and we have a pot that is in bad soil, not getting much water, getting poor sunlight. And those pots, we can't really compare those because the difference between the plants in the two pots is environment. The difference between the plants within the pot, within each pot, is heritability. Because if we have the nice pot where everybody is getting good nutrition, all that other stuff, it's getting water, it's getting soil, all that good stuff, the plants won't be the exact same size. Why not? They won't be the exact same size because of heritability. There's a difference in size and thriving between those plants, and that's what we mean by heritability. So the differences among a population are explained by genes. That is heritability. So really think of those pots again, and I think that will help you understand what we mean by that. And that's really the end of chapter 3. We're going to do some review tomorrow. We're going to do some review on Tuesday. And I want you to study over the weekend. This is the biggest test. It's the hardest test, I think, traditionally. So spend some time looking over your notes. I'll have the Socrative posted, but it's up to you to make sure that you're ready for this test. And I will see you on Tuesday.